Hello there, everybody. Welcome back. This is the second topic that we're going to be covering for organic chemistry, back for more fun. And so what we're going to do in this video is we're going to look at naming hydrocarbons. So we talked about really simple hydrocarbons called alkanes in the last video. Now we're going to see that things inevitably get more complicated. And so we're going to have a system of rules for naming these slightly more complicated hydrocarbons. So an example of one of these is sitting right here, and we can see you've got some CH3s and CHs and so on, and they're all attached together in a chain. And you might look at this and recognize that they kind of look like a chain of carbons, but they also seem to have like a branch sticking off, so it kind of sticks off to the side. So the first rule that we're going to follow when trying to name this thing is we're going to find the longest chain of carbon atoms. So the longest consecutive chain of carbon atoms. Now, I want to point out that when we do this, we could look at this and say, well, that is the 4-carbon chain that goes in a row there. And you'd be right if you said that. But you might also notice that I could have a chain that goes from here around like that. That is also a 4-carbon chain. Either one of those are totally fine. It really doesn't matter which one you choose. We're going to end up with the same result. And that longest chain is what we call the parent chain. And so we've got a parent chain, and then branches are going to kind of stick off of that. So we're going to state the number of carbons in that chain, and we're going to give it our prefix. So it really doesn't matter which way I do it. I'm just going to call this my parent chain there. So there's my parent chain. And I can see that in that chain I've got 1, 2, 3, 4 carbons, and so that parent chain is going to be a butane because a 4-carbon chain gets the prefix but. Okay, so the next step is to identify branches. So what's going on with my branches here? I've got a branch right in this location right here. Branches are called alkyl groups. Alkyl groups. And they are sticking off of the parent chain. Now, the thing is I could move that branch and I could put it in different locations. So in order to be able to tell somebody where the branch is, I'm going to have to number off my carbons so that I can describe the location of that branch. And what I'm going to do is I'm going to number the carbons in the parent chain starting closest to the branch. And we're going to see that this rule is going to get a little bit fuzzy as the compounds get more and more complicated. But basically, I've got a 4-carbon chain, and I could either number it starting with a number 1 here on the left, or I could start with number 1 there on the right. Because these are 3D molecules that are all swirling around, it doesn't really matter which end is written on the page. We don't have to go from left to right. But I'm going to start here in this case and go from left to right. 1, 2, 3, 4, because then I can see that my branch would be on the number 2 carbon. If I started numbering it from the right, then the branch would be on the number 3 carbon, and that would be a bigger number. So I'm going to name each branch. I'm going to give it a prefix according to the number of carbons it contains, and recognize that if it's a branch, it's going to end in YL, ill, instead of ane. So, for example, in this case here, I've got a 1-carbon branch, and the 1 carbon gets the prefix meth, but it's not a methane because that's how we name the parent chain. In this case, this would be a methyl. So I end in ill because it's part of a branch. Now I'm going to list the branches in alphabetical order. Okay, and if there's more than one, branch that has the same number of carbons, then I'm going to point that out by using the prefixes of di, tri, tetra, and so on that we learned when naming covalent compounds. So let's go back and see how this works. Well, this is butane as my parent chain. That branch there is a methyl branch, but I need to tell them where it is, and so this is actually a 2-methyl because it's on the number 2 carbon. So I'm going to put the whole name together, and that compound that I had up at the top there would be a 2-methyl butane. And I just want to point out that we're going to separate numbers and words with dashes or hyphens, so 2-methyl. And if I have multiple numbers, I'm going to separate those with commas. So if I have a 1,2-dimethyl or something like that. All right, so let's look at some examples here. Maybe we'll do the first one together, and then we'll see if you can do some on your own. Now, the first thing I need to do is I need to identify my parent chain. Now, looking at this example here, I can see that there are a few different ways that I can draw my parent chain that are still going to give me the same number of carbons. Like, for example, I could draw a parent chain like this that's going to contain 5 carbons. I could start up here with that carbon and go down kind of zigzag, or I could go down and jog over to the right. No matter which way I do it though, I don't think I can get more than 5 carbons in a row uninterrupted. And so a 5-carbon chain is going to be a pentane chain. So that's my parent chain. The next thing I need to do is identify my branch groups. And so I can see I've got 1, 2, 3 branches coming off of the parent chain. And each of those branches contain just a single carbon. So they're going to be methyl groups that are attached to the parent chain. And so I need to number the parent chain so that those methyl groups get the lowest possible number associated with it. And again, in this case, I think it doesn't really matter which way I go. I could start numbering from here, 1, 2, 3, 4, 5. And if I do that, then my methyl groups will be on the 2, 3, and 4 carbons. If I had started numbering from this bottom carbon, if you work backwards, you'll see that your methyl groups end up being on the 2, 3, and 4 carbons. And so it doesn't really matter which way you number it. Either way, I'm going to end up with the same answer. And so I've got 3 methyl groups, and so I need to tell you the location of those. So those are located on the 2, 3, and 4 carbons. And there are 3 methyls, so I need to call that trimethyl. So 2, 3, 4, trimethyl. And then the parent chain, which is a 5-carbon chain, so that is pentane. So this molecule here is 2,3,4-trimethyl pentane. And while that seems kind of complicated, what you can recognize is if I told you that, that contains all the information you need to draw that exact perfect structure. You could tell me exactly what that looks like just based on the name. Okay, so having done one together, I want you to try these next couple on your own. So pause the video, go and try those, come back, and then we'll see if you got them right. Okay? And now that you have definitely paused the video and you're definitely not lying to a YouTube video that wouldn't know the difference, we'll see what we got for answers. So what is the longest carbon chain that I can get here? Well, again, I've got a few different options of how I could draw it, but at the end of the day, I don't think I can do any better than just going straight across. And that's 1, 2, 3, 4, 5 carbons in a row. If you drew it slightly different for your parent chain, I would expect you would still end up with the same name at the end of the day. And so it doesn't really matter what you choose. So a 5-carbon chain, again, is going to be a pentane chain. And so I need to identify my my branch groups, and I've got a branch there and there and there. And so we can see that where I need to decide which way I'm going to number my carbons. I could start on the left with a 1, 2, 3, 4, 5, or I could start on the right and work backwards. If I start on the left though and make this 1, 2, 3, 4, 5, I'm going to have 2 branches on the number 2 carbon, and I'm going to have 1 branch on the number 4. And those are the lowest numbers I could get. If I flipped it around, I'd have 2 carbons on the 4, 2 methyls on the 4 carbon, and that would be bigger numbers. So I'm not going to do that. So again, this is going to follow the pattern of I've got 3 methyl groups. So I need to tell you the location. That is a 2, 2, 4. And again, it's a trimethyl, and the parent chain is a pentane. Now, the point to recognize here is those two look fairly similar. In fact, they're made of the exact same number of carbons, the exact same number of hydrogens, but by changing the location of one of the methyl groups, I've created an entirely new compound. So this would have different properties. It might have different boiling points and melting points. It might react differently. And even though it's made of the same number of carbons and a number of hydrogens, they're going to give us completely different compounds. These are called isomers. So these are 2 different two different ways that I can combine my carbons and hydrogens that give me a different compound. You can almost think of your carbons and hydrogens as being like little Lego blocks. And if I give you 5 Lego blocks for carbons and a bunch of hydrogens, you can combine them in different patterns. You can see that you can combine them in different ways and still use them all up. And so these two are what we call structural isomers, which means it's made of the same number of atoms, but at the end of the day, they give me a different compound. And we'll see a lot more examples of those isomers as we move on. Okay, let's see what we can do here. So I'm gonna try and find my longest uninterrupted carbon chain, which I think would be if I start here at this carbon and then jog up this way to that one there, because this is gonna give me 6 carbons in a row. So my parent chain there is going to be a hexane parent chain. And that means that my 2 branches are these 2 here. So those are my branches. Now you recognize that those are 2 carbons in the branch, which means they're not methyl groups, they are ethyl groups. So F meaning 2 carbon. And so I need to decide the location. So which way am I going to number it? Am I going to number it from the left or from the right? Well, if I start numbering from the left, 1, 2, 3, 4, 5, 6, I see that the ethyl groups are both located on the number 3 carbon. And if I had numbered them from the right, then it would have been the number 4 carbon. So this is the way that I want to do it. I have 2 ethyl groups, and they're both located on the number 3 carbon. So this might seem like overkill, but I'm going to call this 3, 3, meaning there's 2 ethyl groups and they're both on the 3 carbon. 3,3 di because there's 2, and ethyl because they're both ethyl groups. So 3,3 diethyl, and then I just need to put in the parent chain name, which is a hexane, because that is a 6 carbon chain. All right, last but not least, let's see what we got here. This one's a bit of a mess. So I've got 1, 2, 3, 4, 5, 6, 7, 8. I could name my carbon like this. I think 8 carbons in a row is the best I can do. But the problem is if I make this my parent chain, then you can see over here I've got a big mess that I have to try and name, which is going to be really complicated. So instead, I'm going to choose my parent chain to be a one that's going to give me a little bit of an easier way of naming it. So I've got 1, 2, 3, 4, 5, 6, I'm going to go 7 and 8 carbon. So I'm going to make that my carbon chain. And that's just going to simplify things a little bit in terms of naming my branches. And so you can see here I've got an ethyl group here. I've got a 3 carbon chain, that's a propyl group there, and another propyl group over there. And I need to decide where my number 1 carbon is going to be. And in fact, if I think of my number 1 here from this side, 1, 2, 3, 4, 5, 6, 7, 8, then that's going to give me the smallest numbers for my branch groups. Now I've got an ethyl group on the 3, and I've got 2 propyl groups on 4 and 5. So the way I'm going to name this is going to be 3 ethyl, 4, 5 dipropyl, and then my parent chain, which is an octane. All right, so that is it for naming alkanes.